Yeah, it's me. If you've ever seen my other videos, you might have noticed that drifting cars don't really fit into a game about fishing. And you'd be right. I've kind of run out of things to talk about for Idle Fisher, or at least for right now. You see, I kind of started making Idle Fisher long before I started making YouTube videos. This is why I've been able to post consistently for the last couple of months. But recently, I've been running out of backlog content, so instead of not posting for weeks at a time, why not just work on other projects that I think would be fun? And I kind of need more portfolio pieces because I keep getting rejected. But don't worry, I'm still working on Idle Fisher, I just need a little more time to program. Oh, and since I'm going to be doing a video on something other than Idle Fisher, it's going to be a little weird to look like this. I could put on a disguise, but I don't really want to redraw all my poses. Whatever, you'll just have to deal with it. For a little while now, I've wanted to work with neural networks, because they're just sick. So I thought a fun project would be trying to make cars race using AI. I've come up with some goals for me to consider my AI successful. First is that the car has to run fully on a neural network, meaning that I can't drive it at all. Next, the car has to make one full lap around the track. Finally, the car should be able to drive on a track that it wasn't trained on. Okay, now that we have a baseline, let's get started. First, we gotta actually open up the software, make a blank project, make a car, steal some assets from Google, and set up its components. It's not plagiarizing if I tell you that I'm stealing it, right? Now we gotta make it actually drive. Luckily, the Unreal Engine makes it really easy as it's just a couple lines of code. And of course we gotta make it drift, because drifting's sick. This is pretty easy because we just gotta lower the friction, then lower the deacceleration rate. Oh, and let's add some cool drift streaks. I just gotta make a particle system, change a few settings, and attach it to the wheel. Then just turn on and off the spawning if the sideways velocity is above a certain amount. Perfect, now we get a beautiful moving car. But it's a little boring right now. It's kinda just a plane of grass. But if you've ever seen outside, you might notice these things. These are roads. They're what cars drive on. There are two ways that I can make the roads. The first is to actually open up Blender and hand model a road, but that would be way too easy and fast. Instead of spending 20 minutes modeling two different tracks, I'm going to spend hours figuring out how to use something called a spline. This is pretty much a magical line that I can add a mesh on top of to move around very easily. Instead of being creative, I'm going to just look up an F1 track to copy. This one looks like Phineas trying to swing his arm like an old-timey boxer. Beautiful. Oh, and it took me a lot longer than I'd like to admit, but when the cars fall off the track, they blow up. That's a little loud. I can't possibly imagine that when having hundreds of cars that'll hurt my ears.
Oh my god, stop, it's so loud, I can't hear.
I'll figure that out later. Now it's time for the actual AI part. I'm going to be using something called a genetic neural network. If you don't know what a neural network is, it's this thing. That looks scary. Pretty much what a genetic neural network does is selective breeding. Spoilers, but if you've ever seen... It's like when the Viltrumites kill the weak and only the strong are left.
A long and
Oh my
difficult
god, that's
process.
horrible. That's exactly what the genetic neural network does. I'll go more in depth in a second, but imagine we have cars that are very good at driving and other cars that are horrible. The algorithm essentially kills off the bad drivers and breeds together the good drivers. This process is then done over multiple generations until we have the ultimate drivers that can completely drive around the track as quickly as possible. But how do we actually know what drivers are the best? With Viltrumites, you just do a quick fight to the death. But cars don't have hands. Instead, we have to look at something different. With humans, our brain releases a feel-good chemical called dopamine, which is just like the reward system of our neural network. When humans do stuff like eating food, our brain tells us it was a good thing and to do it more. When we do stuff like getting injured, we get the opposite of a reward, and we know not to do that again. But that doesn't answer the question of how do we know a car did the best. In this case, we look at how far and how fast the car went. The further and faster they go, the better they do. But the slower they are and the sooner they fall off the track, the worse they do. This is then calculated into a score, called the fitness score. The fitness score controls the entire network. It's literally just a number. This is like the human version of heroin. Do not underestimate this value. From here, we keep the top 20% of the cars and remove the other 80. Whoa, hold on. I'm getting a little ahead of myself here. Let's go back to the very beginning. First, we need to define the inputs and outputs for our network. First, let's think of the outputs, or rather what the car can do. Luckily, we've pretty much set this up already. The car can move forwards and turn left and right. Pretty simple. But now for the inputs. These are a little more complicated. For humans, inputs consist of things like vision, touch, smell, and the other senses. In this case, humans would see the screen and do some advanced calculations that we spent millions of years developing to convert vision inputs to finger movements, to keyboard presses, to finally the car moving left and right. But given the neural network, screenshots of the game every frame is a little computationally heavy. Luckily for us, computers can actually be smarter than humans. Since I'm going to have multiple cars on the track at the same time, this means that if the program uses a screenshot every frame, the cars might not be able to see the track. Instead, we can use some computer magic to get other inputs. The first input, or the first 5 inputs, are going to be the distance the car is away from the track. This can be done by casting multiple lines in front of the car. This gives the car the ability to see its location on the road. The next input is the car's speed. This will help the car know how fast it's going, so if something like a turn is coming up, it could slow down to adjust for it. The final input is the angle the car is against the road. This is just another input to help the car understand how misaligned it is from the road. Now that we have our inputs and outputs, we need to actually get the cars to drive. This is a process called forward propagation. This is when we go through each neuron, get the weighted sum of all the inputs, and add the bias value. Then repeat this until we get to the outputs. Then plug these values into the car's driving. The first one's being the acceleration, and the second one for turning. Now the cars are able to drive. But if we run this for multiple generations, you'll see that the cars kind of keep falling off the edge. We occasionally get a decent one, but it doesn't look like they're overall improving. This is because we aren't actually training them yet. They're currently just spawning in with random weights and biases. This is what the next step's for. It's called crossover. Once we've taken our top 20%, like I mentioned earlier, we have to breed them together. Whoa, not on YouTube. Crossover is the process in which the parent cars will make a child that has 50% of one of the car's genes and 50% of the other car's genes. These genes are just the weights and biases. And to anyone who took biology, this is a similar process to meiosis. But I also failed biology, so this could all just be completely wrong. The parents are picked randomly from the top 20% of the cars. But don't worry, I made it so the cars can't breed with itself. That would just be weird, and it would just make clones. We already have those. Then we do another process to all the child cars called mutation. Mutation is when each bias and weight have a small chance to randomly mutate. And by mutation, I mean to just randomly change the weights and biases by a certain amount, which is called a mutation step. The higher the size of this value, the more random the AI will be. If the value is too low, then the AI will take too long to train. The reason we don't make the chance to mutate 100% is because it will kind of just break the network. I have set the chance to mutate at 5%. This is similar to how DNA in a living creature would make a mistake. Having a small mutation might do something as simple as changing your hair color, but having a bigger mutation might cause you to grow an extra finger. If DNA had a 100% chance to change every time people had a kid, then it would be like pretty much rebuilding the human blueprint from scratch, which would pretty much just end up being lethal. Now let's run it to see if all this works. Okay. Looks pretty normal so far. Wait, why are these cars just going in loops? Let's take a look at their fitness score. You can see it's kind of just infinitely going up. The current way I have the cars gaining points is by a checkpoint system. When the cars collide with this object, the score increases. But the network kind of figures out that it could just drive in circles infinitely to get infinite points. So after a little messing around, I figured that Unreal Engine has a function that converts the car's position into a distance on the spline. Now the value is continuous, so if the car goes backwards, it loses points. Okay, let's run it again. That didn't fix anything. Why are they still going in circles? After a while of trying to figure this out, it's kind of just how the network works. There's a chance that the cars just get stuck turning in one direction forever. This means that we need to destroy the cars if we don't progress after a little while. Okay, this should finally be working. Let's try to run it again. Nice, looks like it's working. Let's run it for a few generations to see how it does. Only after a few generations, you can already see them starting to improve. Let's go! Only after 17 generations, it completed a lap. Well, that means one more thing. Time to put it on a track that it hasn't trained on. This one looks like a rock doing a front double bicep. Well, let's see if it could do a lap without it crashing. Oh, that didn't do so good. Well, I'm gonna run it for a few more generations just to see how long it actually takes. Wait, he's actually cruising. Let's go! It only took one more generation. I'd call that a pretty successful AI. It's kind of crazy that these are all just random numbers working together to make a car drive around a track. Well, that was actually a pretty fun project. Leave a comment down below if you like this little side project and if I should make more videos like it, or if I should just stick to the idle fisher. Okay, see you next time.